So let's actually carry out our hypothesis test on the model utility for the example that we've been looking at between medication dose and pain level, headache pain level. So recall that our model y hat was given by 8.478 minus 0.00861x, and sum of squares of xx was 287,500. So we want to conduct a test at the alpha is 0.05 level to determine if y is linearly related to x. So this is just saying a linear relation. In other words, what we're trying to test here is beta 1 not equal to 0. So if the slope is not equal to 0, there is a linear relationship. So our null hypothesis here is going to be that beta 1 does equal 0. And then we're just testing linear relation. So it doesn't say positive or negative linear relation. So our alternative hypothesis is beta 1 not equal 0. Step 2, we select our significance level. That was given to us, 0.05. Step 3, we're sketching our rejection region for the distribution curve and determining the cutoffs. So this is the sampling distribution for beta 1 hat, is our x. Mean of that sampling distribution is beta 1. Of course, we're going to look at t values though. So we are doing a two-tailed test, so there are going to be two rejection regions here. One on the right and one on the left. So, and then our t sub alpha over 2. So alpha is 0.05, so alpha over 2 is 0.025. And then this t alpha over 2, which is t.025, is going to be equal to, we're going to do inverse t. And then the right area is 0.025, so that means that the left area is 0.975. So remember, you always input left area. And then degrees of freedom, 4 minus 2. Remember here that n was equal to 4, and degrees of freedom are n minus 2. So go to the calculator. And so we want to do second variables to go to the distribution menu. Inverse t is number 4. Our area 0.975. Degrees of freedom 2. 4.303. So 4.30 to 2 decimal places. So this would be 4.30. And then negative t.025 is going to be negative 4.30. So I haven't drawn that to scale, but plus or minus 4.30. Now we compute our test statistic, which is going to be the value for beta 1 hat. Remember, this is beta 0 hat and beta 1 hat. So beta 1 hat, the slope there, so negative 0.00861. And then we're dividing by s over the square root of sum of squares of s of xx. So the sum of squares of xx right here. And then we had previously computed our standard error s to be 0.8486. 8497 was closer. I will go ahead and use the 0.8486. So 0.8486, and dividing by square root of sum of squares of xx, which was our 287,500. And let's compute that in the calculator. So negative 0.00861. And then we are dividing by, let's do some parentheses here. So 0.8486 divide by square root 287,500. Close up our parentheses, negative 5.44. So our test statistic, negative 5.44, out here somewhere. So there's our t-test, negative 5.44. And if it falls in rejection region, we reject the null. It is in one of the rejection regions. So t here, which is negative 5.44, is less than negative 4.30, which is telling us that we reject H0. And then we'll state and interpret our conclusion. So we would say that there is sufficient evidence to conclude the alternative hypothesis. To conclude that beta 1 is not equal 0. So i.e. X and Y are linearly related. Part B, we want to compute and interpret our p-value. So the p-value is the area past the test statistic here. And since this is a two-tailed test, we have to multiply that area by 2. So this is going to be 2 times TCDF. And then the area past negative 5.44. So the left-hand cutoff would be negative infinity. We'll use negative 10,000. Right-hand cutoff, negative 5.44. And degrees of freedom are 2. So let's compute that on the calculator. So 2 times second variables. TCDF number 6. Negative 10,000 for our lower. For our upper, negative 5.44, degrees of freedom 2, paste it, 0.0322. And we notice that that is less than 0.05, which was our alpha, so it's still telling us to reject from the p-value method of doing a hypothesis test. Interpretation, if we had 10,000 samples that were collected, then this is 322 out of 10,000, so 322 of them would yield results at least as extreme as this sample. And then we can also carry out this hypothesis test on the TI-84. You put your data in list 1, list 2, and you do stat test lin reg t-test. Stat tests lin reg t-test. So there should actually be space in there. Like so. So let's go to the calculator, stat, tests, and then lin reg t-test is way down at the bottom. I'm going to arrow up. So right there, option F. Enter. List 1, list 2 for X and Y. Make sure that we're doing a not equal test, two-tailed test. So that's already highlighted. Come down to calculate. And we're testing beta not equal 0. There is our test statistic, negative 5.43. We got 5.44, a little bit of round off error. Our p-value, 0.0322. We got that. And it gave us our model coefficients here. There's our S, 84955. Again, a little bit of round-off error compared to the one that we used. We had a little bit of round-off error. This one is accurate to as many decimal places as we have there. So that's confirming what we did by hand. Now note that p-values from statistical output are almost always reported as two-sided p-values. So if we were to do this test in Jamovi, it would most likely report a two-sided p-value to us. And then just a caution, in your simple linear regression, when you test beta 1 equals 0, that's only going to be meaningful if the value x equals 0 makes sense and is within the range of the sample data. So if x equals 0 doesn't make sense, not in the range of the sample data, then this hypothesis test is not going to be meaningful.